Welcome to remembrance-kjv.com. This is video number 3. Let us be frank and candid, ladies and gentlemen. To talk of advanced form of mathematics in Africa before colonization sounds more like propaganda. Whoever tries to forward such a mind remains a babbler until he or she proves otherwise. But the time is due that truth should verify itself before every other thing that human race may deem controversial. Let us take a look at some of the controversial observations that were associated with the educational history of Africa, and more specifically with the mathematical records of Africa. When Fuller was alive, people from as far as Philadelphia would require to witness his genius computations. He wasn't far from bringing light to the Americas. But after his death, some of the psychologists and psychiatrists began to say something negative about him. Some began to call him an idiot servant. An idiot servant is someone who is known to have servant syndrome. This refers to someone who is mentally defective but having an exceptional skill or talent in solving, say, complex mathematical problems mentally at great speed. Why call him an idiot servant? Simple, they failed to decrypt his arithmetic algorithms. Remember that on the other hand, Thomas Fuller referred to learned people as fools. This misunderstanding between psychologists and Thomas Fuller can only be understood as arising from conflict between systems of education. One of the stumbling blocks in Western education system is the belief that writing is a prerequisite for mathematical thinking. Since Fuller was illiterate, this is most likely why some of these psychologists placed doubt on his arithmetic talent. It isn't correct to say that writing is a prerequisite for mathematical thinking. In the presence of mathematical apparatus, mathematical calculations can be achieved with limited writing. The African school of mathematics is alien to the European school of mathematics. The same PDF by John Fauvel and Paulus Guez cites Thomas Clarkson, a fervent anti-slavery campaigner, on records related to observations that were made on the west coast of Benin. Let me quote, "It is astonishing with what facility African brokers reckoned up the exchange of European goods for slaves. One of these brokers has perhaps 10 slaves to sell, and for each of these he demanded 10 different articles. He reduces them immediately by head into bars, coppers, and ounces according to the medium of exchange that prevails in that part of the country in which he resides, and immediately strikes a balance." End quote. The record mentions the word astonishing. This makes me think of two aliens meeting one another, each with its own way of doing things, but the one that thinks to be wiser is defeated by that which it despises. I have also taken interest in the phrase medium of exchange. I have taken the phrase to mean number base. If so, then these Negroes could carry out number base conversions mentally. It is quite remarkable that this research is also going to clarify on how these number-based conversions are carried out mentally. In 1886, Dr. Oskar Lenzi, the German geologist, recorded of what he referred to as mysterious calculations he observed among the people of Timbuktu. He would not have called the calculations mysterious had they not been contradictory to what he regarded as correct. A year later, man also recorded similar calculations among the people of Yuruba. In their calculations, Yorubans used the bigesimal number system, that is base 20. Man referred to those that could interpret the calculations as magician calculators. Why call them magician calculators? They exhibited calculations that were beyond his reasoning standards. Worse still, that these calculations were carried out in base 20. Africa had no single number base. As records do prove, there were several of them. So, for Europeans who were trained in the mathematics of specific number bases, it was a challenge for them to encounter champions of multi-base arithmetics. Let us turn to the text A History of Mathematics by Boyer and Mesbach and listen to what Herodotus say about the African abacus. From page 55, it reads, Herodotus, writing in the early 5th century BCE, said that in counting with pebbles as in writing, Greek hand moves from left to right, the Egyptian from right to left. As we are going to explain in later videos on the use of the abacus in number operations, many will realize that this controversial observation was due to the fact that Egyptian or African number operations were carried out from left to right, while Greco-Babylonian number operations were carried out the reverse. Therefore, the strange observations of the 19th century were not new phenomena. Herodotus' record was the first record that Africans computed numbers beginning with most significant digits, a proof of the use of mental arithmetics. Let us take a look at some of the things that do remain controversial in mathematics even to date. Let us begin with demonstrating modern-day multiplication of numbers. We have 12 multiplied by 13. Each digit of the multiplier will independently multiply each digit of the multiplicand. We begin with 1. But this 1 is 10 by virtue of its positional value. Therefore, multiplying any natural number by 10 will give the number of tens. This means that there is no unit value in any multiplication in which tens are involved. That is to say, the unit value in the multiplication involving tens is 0. So, it is 1 by 2, and we get 2. 1 times 1, that's 1. Next, we multiply using 3. It's 3 by 2, that's 6. 3 by 1, that's 3. Then we add the products. 0 plus 6, that's 6. 2 plus 3, that's 5. 1 plus nothing, that's 1. The final answer is thus 156. But this multiplication is so compact that we require further clarification by looking back at how it could look like before positional notation was introduced. 12 is 10 plus 2, and 13 is 10 plus 3. We multiply beginning with 10. In this case, there is no unit value, or simply the unit value is 0. 10 times 2, that's 20. 10 times 10, that's 10 squared. Next, we multiply using 3 units. 3 times 2, that's 6. 3 times 10, that's 30. We now add units to units, tens to tens, and squares to squares. 0 plus 6, that's 6. 20 plus 30, that's 50. 10 squared plus nothing, that's 10 squared or 100. The solution is 100, 5 tens, and 6 units. A value that by positional notation is 156. I believe that everything is now made simple and easy to understand. From what we have understood here, let us turn towards algebra and take a look at modern-day approach to algebraic calculations. The same numbers, 12 and 13, can be represented algebraically as x plus 2 and x plus 3 respectively. In this case, x is representing the Roman numeral 10. In the process of carrying out multiplication, every digit of the first bracket multiplies every digit of the second bracket. Therefore, it's x times the second bracket and then 2 times the second bracket. That's the first stage. Next, it is x multiplied by x and x multiplied by 3. The first bracket is cleared. Then it's 2 multiplied by x and 2 multiplied by 3. The second stage is complete. The result is x squared plus 3x plus 2x plus 6. Summing up 3x and 2x gives 5x. The final result is x squared plus 5x plus 6. The calculation is complete. If we take x to be the Roman numeral 10, then the result is interpreted as the square of x, or 100, plus 5x, or 5 tens, plus 6 units. This value in positional notation is 156. Let us list some observations and insights that can be drawn from this calculation. 1. Algebra can be used to facilitate numerical calculations. 2. Algebra employs a left-to-right approach in dealing with number operations. 3. Algebra uses non-positional notation, and in general, it denies the existence of 0. Before we can argue anything in line with these strange phenomena, let us try and compute the same algebraic multiplication in the same manner as we did previously with the numerals. It's x plus 2 above multiplied by x plus 3 below. X is 10 and multiplication with x gives 0 units. X times 2, that's 2x. X times x, that's x squared. Next, we multiply using 3 units. 3 times 2, that's 6. 3 times x, that's 3x. Then, we move on to add the partial products. 0 plus 6, that's 6. 2x plus 3x, that's 5x. X squared plus nothing, that's x squared. The final result is x squared plus 5x plus 6, which is the same result as in the previous calculation. But why is it the case that algebra is not taught using this approach so as to marry it with numerical computations? Is it that the mathematics world is reluctant to reform? Why is it treated the way it is treated? If people read about the first record on algebra from texts like Robert Chester's translation of Al-Muqabbala, that is what the so-called father of algebra, Muhammad ibn Musa al-Khwarizmi, teaches. The PDF text can also be found from the internet, and I have provided a link to it. Coming back to the strange observations about algebra, we should realize that al-Khwarizmi was a Muslim. Muslims are Babylonians. The left-to-right approach in treating algebraic computations has no origins within the Greco-Babylonian culture, a thing that can be inferred from observations that were pointed out by Herodotus of Halicarnassus. Muhammad ibn Musa al-Khwarizmi is therefore not the founder of algebra. He observed it elsewhere outside the realm of Greco-Babylonian system of education. Evidence gathered in this research points to Africa as the home of algebra. And artifacts used to demonstrate these algebraic principles are in abundance across the continent. But remember that x can take any value, meaning to say that it can be taken to represent any number base, just like 10 can represent any base. It should therefore be possible to carry out calculations in any number base using algebraic algorithms. This gives the insight that algebra originated from a multi-base community, the nature in which we find Africa before colonization. Let us try and see how algebra can be used in multi-base arithmetics. They are the same numerals, 1, 2 multiplied by 1, 3, but now in base 8. First, convert the numbers to their algebraic equivalents, x plus 2 and x plus 3 respectively, where x is base 8. Expand the brackets and simplify. This gives 1x squared plus 5x plus 6. Powers of x should be taken to represent powers of base 8. The coefficients of these base powers will represent the positional result of this multiplication. The solution of 1, 2 times 1, 3 in base 8 is therefore 156 base 8. Another example using the same numerals in base 4 gives this result. But remember that none of these coefficients should be 4 and above. They are therefore supposed to be converted this way. 6 divided by 4, that is 1 and a remainder of 2. Then it's 5 plus 1 and that's 6. 6 divided by 4, it is again 1 and a remainder of 2. The coefficient of x squared is 1. 1 plus 1, that's 2. The result is therefore 2, 2, 2 base 4. Let us try yet a little challenging example. 8 multiplied by 4983 base 12. In School's method, 4983 base 12 is first chained to base 10. Then it is multiplied by 8. The result is then converted to base 12. Excellent, it works. But let us use the algebraic approach. 498 and 3 are coefficients of powers of x, in which x is base 12. When each of them is multiplied by 8, none of the results should affect the neighboring positional value. Let us multiply 8 times 4, that's 32. 8 times 9, that's 72. 8 times 8, that's 64. 8 times 3, that's 24. We have chosen to represent partial products in green because they are in base 10 and not in base 12. Base 10 is the base in which most of us are accustomed to. These partial products are the ones that are supposed to be converted to base 12. Let's begin. 12 into 24, that's 2 and a remainder of 0. 2 plus 64 is 66. 12 into 66, that's 5 and a remainder of 6. 5 plus 72, that's 77. 12 into 77 is 6 and a remainder of 5. 6 plus 32 is 38. 12 into 38 is 3 and a remainder of 2. The solution is therefore 32560, base 12. We are done. Isn't that very simple? I do hope it is. The computation can be done without the use of base 12 times table. How much more will this be simplified when people shall come to know the in-depth of mental arithmetics? The list of topics to be covered includes measures. These are Bible metric units. One surprising thing is that these measurements are the ancient metric system of the nation of Zimbabwe. How Moses got them, that's another subject. Feel free to study Zimbabwe's tradition, for some of the things that are despised by religious people will be found to explain the Bible better than any man can imagine. Choose to subscribe to this channel and be part of the reforming people. Thank you, and meet you in video number 4, where we shall begin with exploring the psychological nature of human mental arithmetic memory.